Hi there. Today we're going to work on 8.4, talking more about the equations, and we're going to take an equation and we're going to graph it. We're going to find some stuff out about it, and then we'll do our best to graph it, and then I will show you a different way to find these values and how to graph it. My dogs are seeing someone outside, so if you hear some weird huffing noises, it's them kind of being upset that someone's outside. Okay, so here's my equation. This is a cosine curve, but remember, sine curves and cosine curves are best friends. They look just the same. One's just shifted over to the right or left, just depending on how you think about it. So really, sine and cos, same ideas, no problem. Let's start off by finding some of this, because this will help us make our graph. So first things first, amplitude. Remember, that is the, maybe I'll write it in here, y equals a, often it's sine, and then we have b, x minus c, plus d. So amplitude is the a value. That's probably the easiest one to remember. Amplitude is 3. That's like the height of the function. Equation of the midline, that's the d value. That's minus 2. But we don't just say minus 2. We say y equals minus 2. Maybe I should put a dot dot instead of an equal sign there. It's a line, right? It's not a point. Range. Okay, now let's start drawing stuff on here. I'm going to use pencil, and I'm going to do it really lightly because this is not going to be part of my graph. It's just going to help me figure out what's going to be on my graph. So if the midline is at -2, -1, -2, I'm going to put a dotted line right there through y equals -2, and I'll give it a label. Y equals -2. So that's going to be kind of the middle point vertically through my graph. Now from there, we're going to go up 3 and down 3. And I'm just going to add stuff on here just for me to look at it. It's really not part of my graph. It's just to help me kind of graph it later. So up 3 would be 1, 2, that'd be at 1. I'm going to put another dotted line because it's really not a part of my graph. It's just to help me a little bit. I don't know if that lamp makes it better or worse. Let's label that y equals 1. Our maximums will be on this line. Now the minimums, we're going to go down 3. So down 1, 2, 3, -3, -4, -5. Y equals -5. So our graph is going to live in between these lines, where that's the middle, that's going to be the top, and that's going to be the bottom. So range, the smallest value will be -5, the biggest value will be 1. Alrighty, period. Period is one where we can't just read off of our equation. We have to do a little bit of calculation. It's related to the b value, which is 2. Now, this question is in degrees. So I'm going to use degrees to try and figure this out. So period equals b, 360, 360 over b. I haven't done this in a while. Okay, so 360 degrees divided by 2 is 180 degrees. So my cycle is going to begin, and it will take 180 degrees in the x direction for it to start to repeat. Every 180 degrees, it will go through one full cycle, and then graph the equation. Okay, I'm going to switch back to pencil here because I'm going to make mistakes. Let's just be honest with ourselves. I'll make mistakes. Now I'm going to write out a list of steps, and if the list of steps helps you, great. If it doesn't help you, that's totally fine. That's super reasonable. This is a hard topic. I'm going to show you this way, which is kind of the by hand way. There's a slightly different pre-cal way, which I might go about it, sometimes, just depending. And then there's going to be the calculator way. So there's lots of different ways, and maybe you kind of piece them together to make your own way of how to do this. Now, I'll be totally honest with you. I don't really expect you to get this question on your exam. I don't really expect that, but I have no idea what's on your exam. So we go a little bit deeper than what I think you're going to get, just in case, just in case, because I really don't know what's on there yet. So here's my steps for you, going straight off an equation. First, find the midline. which we did. Draw a line on your graph, like draw it on there so you can kind of see it. 2, use your amplitude to find max, min values. So I know where the tallest value is going to be, and I know where the shortest and tallest doesn't really make sense, but the greatest and lowest values, I know where those are going to be. 3, find the period. In this case, we use 360 divided by b, or sometimes we might use 2 pi divided by b, depending if we're in degrees or in radians, and you know that based on what they give you in the question. We have 45 degrees right there, and this is in degrees, so we're in degrees. That's how I know that. 4, probably could use pen for this part, but that's okay. Find the starting point. Now this is what we still need to do here. Find the starting point. A sine curve will start at the midpoint. It will go up, it will come down, and it will come back. That is what a sine curve looks like. A cos curve starts at the max. It goes down, all the way down, and then back up. So that's what I'm talking about the starting point. Like at x equals 0, what are we doing? Now the thing is, on your graph you might have a phase shift. So we have to deal with the phase shift. So use phase shift. Phase shift. So it says x minus c. If that is a minus, we would shift, oh my gosh, to the right, which is a little counterintuitive, but there's a reason for it. If it was a positive, we would shift to the left. So let's do that part right now, okay? This is a cos, I should label it on there. Okay, so let's try this one. So normally, my starting point would be at, let's see, we have a cos curve. So normally our starting point would be at the maximum. So I'm just looking here. I see that cos. Normally it'd be the maximum. The maximum is right there. But we're shifted to the right 45 degrees. You don't know, I'm thinking about it. This would be a great time to have x values on here, wouldn't it? So they asked me for x values between negative 180 and 180. This x business just says x such that x is between negative 180 and 180. So let's put 180 degrees on here. Got to use degree symbols, and then I usually just kind of split it up by halves. And then we'll do that phase shift. Okay, good. So now let's do the phase shift. So normally, cos curve would start at the maximum, but it's telling me that we are shifted 45 to the right. So instead of starting at this y-axis right here, this starting point is going to be moved over to the right 45 degrees. So that is my first point. Nice. Number 5. I'm running out of room. We'll get it moved in here. Let's use the period to find the last point in the cycle. Now this is where you might do something a tiny bit different because maybe something else makes a little bit different sense to you. I find this makes sense to me, so this is typically what I do. What I mean by the last point, and it's not the last point, it's just where do we start to repeat. So on a cos curve, this would be the last point. It's where we start to repeat again. Sorry, on the sine curve. On a cos curve, this would be my last point. It's where we start to repeat. And what I mean by use the period is I know on my curve up here, it's going to take 180 degrees for this to happen. So for example, I would have to be I'm at 45, I'd have to go another 180 degrees, which would take me to 225 degrees. That would be my last point in here. Now I don't have that on here, so I'm gonna add it in, and I'm gonna do it really lightly, just to cheat just a little bit. So my last point would be right here. Now I'm going to put it lightly because they wanted me to stop at 180, so I'm technically going to stop there. I'm just doing that for my own reference. Okay, so that's my last point. My coast curve is going to be up here. It's going to go down and come back up. Last step, and then we're basically done here. We've done all the hard parts, is use the middle. Shh. Dogs are growling. Oh, Penny, get down. Use the middle to find other points. All right, which I know is pretty vague. So I'm just going to draw this up here real quick. A coast curve starts at the top, it goes down, it comes back to the top. And this is a beautifully symmetrical thing. And the same thing is true for a sine graph. This is beautifully symmetrical. Which symmetrical means that this side looks exactly the same as that side. Just like if there was a mirror right there in the middle. So that means that this happens halfway in between. Halfway. So in between my 2 points here, there is going to be a minimum halfway in between those two things. So sometimes what I do is I just count ticks. There's 1, 2, 3, 4 ticks in the way. So halfway between that would be 2 ticks. So right here, that's halfway in between. There's going to be a minimum point right there. Now, looking back here, I didn't draw this perfectly, but not bad actually. Halfway in here, there will be a midpoint. All right, so halfway between here and here, there's a midpoint. So halfway between here and here, we're going to be at the midpoint. So at 90 degrees, we'll be halfway in between. And the same is true for the other side. Halfway between this point and that one, there will be a midpoint. And then you can see the graph, right? It goes down and comes back up. And I can see the pattern now. Every 45 degrees, I kind of make another step. I really only care about the max, mid, and midpoints. I don't really care about any points in between because this is enough to graph it. So to go left, every 45 degrees, I'm going to take kind of one step. Oops, I almost botched that one. And then I'm going to connect it with a line. I try to make it as curvy as I can because it's not a V shape, it's more of a U shape. I just stop right there because that's not really part of my graph. No arrows on this one because it does not say to go to infinity. So I stop and I'm done. Here's the other way to do this question. You know what? There's another question on the next page. Let's do the next question on that page. Let's do it the other way. So let's give it a flip. Let's try this one. I did change one value on here. I changed this to pi by 4 right here. This. Trying to think if I want to. Yeah, let's do it. Pi by 4. Alrighty. Now let's do this the calculator way this time. If you would like to do this the hand way, you go ahead and do it. You can always double check with us back in a minute. It's good practice. But we do have a calculator, and that is a good tool to use. So let's try it. Okay. I'm going to try and graph this in my calculator. So I'm going to clear the junk I had in there, and I'm going to type this into my calculator. Now, the only thing about your calculator that's kind of weird is you can graph coast curves. Like you could put cos in here and it would graph it. It always opens a bracket after the sine. So it goes to sine, it will open a bracket right there. And if you open a bracket, you have to close a bracket. So the place I'd want to close it is right after here before that +2. So it's going to open one, I'm going to have to close it. Okay, it's just kind of like a weird, I guess it's supposed to help you? I don't know, but here we are. So I'm going to go to sine. It opens that bracket. I put a 4. I want another bracket, so I'm going to open another one. X minus pi divided by 4, so I'll throw a pi on there, divide by 4. I need to close the bracket I opened and the one that it opened for me. So I have 2 brackets that are closing, and then I say plus 2. So if you get something different than I do, please double check that. And then the other thing we need to check here is which degree or radian we're in. So I just want to show you this first. If I'm in degree and I hit graph, oh, it's actually not that bad. Sometimes it goes crazy. There's what my crazy looks like. So that's not really what I'm expecting to see off of a graph, right? That is not the shape that I'm looking for. So if you get a shape that's not what you're looking for, we're just going to change your calculator over to the other one. So in this case, you would like degree, which is actually surprising to me, but whatever. Oh, I see what the problem is here. Okay, so let's change our window settings actually. Okay, I wish I hadn't done that, but that's okay. Let's change our window settings. So our window wants to be from 0 to 2 pi. So I have it from negative 180, which is way bigger than we need this to be. I want this to be from 0 to 2 pi, and I can type that right in there. It changes it to a decimal, but that's okay. Let's go by ones maybe. My y's actually seemed alright, so let's take a look at that graph. Okay, now that's not what I was expecting. So changing my window really changed this quite a bit, but since they gave me the window, I think I should probably stick with that. So here's where radians makes a lot more sense to me. And now it fits in with what I'm looking at here. So this is in radians. I should probably be in radians, and I have to adjust my window settings. And this just says x is between 0 and 2 pi. So the smallest x is 0 and the biggest x is 2 pi. So this is what my graph on my page should look like. Now the thing is, I have a hard time taking this to paper. I have a hard time graphing this on my own. So instead of trying to graph this on my own, I'm going to use my calculator as a tool. I'm going to make myself a little table of values over here. X, Y. Now really, I know what the shape is going to look like. I have a picture of it right here. I really just need a few points to get myself going. And if I take the important points like the mins and the maximums, I should be able to graph this with no problem. So why don't we find all the minimums and let's graph them. So second trace 3 for minimum. I have to move myself all the way over there. My cursor's moving. Because you have to get close to the one you're talking about, right? It says left bound, so I have to go on the left-hand side of my minimum. So right now, that's pretty much my minimum. I have to go on the left-hand side of it. Anywhere on the left, really. Hit enter. Move to the right-hand side of it. Hit enter. Enter one more time. X equals 0.39. Y equals something with this. It's called scientific notation. The exponent is negative 12, and that's a really, really tiny number, which means it's basically 0. Like this would round to 0. It would be like 0.000000052. So it rounds to 0. It's just not, it's not perfect, that's all. Let's find the next minimum. So I'm just going to leave a space, and then we'll find the next one. Second trace, 3 for minimum again. Now I'm going to move over to the next one. So there's my next minimum. I go to the left of it, hit enter. Move to the right of it, hit enter, enter one more time. X equals 1.96. Y equals a really, really tiny number that would round to 0. Let's just find one more and then we'll call it quits on that. Find one more. So let's go to the left of the next one. Hit enter, move to the right of it, hit enter, enter one more time. There we go. 3.53, y is 0. Now what we should see is these values go up by the same amount every time. So what's the difference between 1.96 and 0.39? Let's find out. 1.96 minus 0.39, 1.57. So this, to get from here to here, it should be going up by 1.57. So 3.53 plus 1.57. Whoops. Oops, I looked at the wrong one, didn't I? 1.96 plus 1.57, 3.53. So I can guess the next one. It's going to be going up by 1.57. 5.10. I can find all of them doing this. I can just keep adding 1.57 every time. Let's find the maximum points. So go back to my graph. Let's find maximum points this time. 4 for maximum. Oh, someone's calling me. My sister here. Alrighty, coming back to this. So we're finding the maximum. So it asked me for left bound. I'm going to find that one up there. So I'm just going to move until I'm on the left-hand side of it. Just crawling along there. Okay, now I'm firmly on the left. Hit enter. Go to the right. Hit enter. Alright. 1.18 and y equals 4. And you'll notice here too, this step should be the same. So the difference between this and this should be the same. Difference between this and this should be the same. I'm going to use my calculator to find another one, but then I'm going to just do the other ones by hand. So second trace, 4 to find maximum. Because this is kind of boring watching this, you know, like, whoops, I made a mistake here. Try that again. Left bound, move over to the right. There we go. Okay. So 2.75, y is 4. And then, yeah, I'm going to cheat a little bit. I'm going to use just thinking for this. So let's see how much this goes up by. So I'm going to go 1.18 minus 0.39. So the step here is always 0.79. So each time I'm going up by 0.79. So to find this value right here, I'm going to go 3.53 plus 0.79. Oh shoot, and I typed it in wrong. 0.79, there we go. 4.32, and the y value is 4. And that would just keep continuing. I could find maximum, minimum, maximum, minimum, maximum, minimum, till I die. This time they told me the domain is between 0 and 2 pi, and since I've been working in decimals, I think I'm going to continue working in decimals. So let's find out what 2 pi is as a decimal. 6.28. So let's make that, let's make this 7 perhaps. Ooh, I'll try and space myself out. 1. Oops. Okay, I need one more. Did not space it out right, but that's okay. 7. There we go. Alright, so let's throw some maximums and minimums on here, and then maybe we have to add maybe a point or two more just to have enough points to fit on this thing. So when x is 0.39, so a little bit left of half there. Oh, and I should add some on here too, shouldn't I? A little left of half, we're at 4. 1.18, maybe around here. We're at 0. Certainly not perfect, right? But I'm doing the best I can here. It'd probably be better if I had graph paper, but yeah, that's fine. We're going for all right. We're not going for perfect. 4.32. And I should have moved my table over apparently. Let's find some more values. I'm going to add 5.10 plus that 0.79 that we figured out. So 5.89, and I know the next thing that would come would be a max, so that should be 4. Let's add 0.79 again. 6.68. Okay, so that's a little further than we should be here, so that'd be 0. Okay. So 5.10. Oh, I had that one. Okay, and now I know what this is going to look like. It's going to be this curvy up and down business, so I'm just going to draw it in. So this time I used my calculator to find out a bunch of things. I basically used it to graph, and then I found some important points. And that was able to give me everything that I needed off of here. So this is kind of the applied method of finding this. Let's fill in the rest of the stuff just so we can finish off the question. Amplitude, 2. Equation of the midline, well I can see that on here right here, or I can see it right from here, 2. Y equals 2, that's an equation. range, where we're going from 0 to 4. All of this stuff we could figure out without our graph, but since we have our graph, may as well use it. Period. Okay, that's not one that I wrote down. I could calculate it, or I can use my table of values. Now remember, table of values, or off of a graph even, is we pick a point and we see where that point happens again. So I could look at maximums, I could look at minimums, and we just want to know how long does it take for that point to happen again. So from example, from one minimum to the next minimum, 1.96, I can't remember what that is now, 1.96 minus 0.39, 1.57. As in, every 1.57, we go through one full cycle. So that's my period. You can prove that to yourself by going 2 pi divided by 4 as well. So that's how we can do this in a different method. If you like this method better, great. If you like the other one better, great. I don't care. Use what you got to use. Figure it out. Let's flip the page and do some matching, and then we'll stop for today. I'm just skipping these questions at the bottom. You can do this on your own. Let's do a little bit of matching, where we're mostly looking at the phase shift, if I remember correctly. All right, so let's identify some of these things on here. So these are the two graphs. They should match up to 2 of these in here. So let's try and read off the graph and let's find some stuff. One thing that I noticed that's different is the amplitude. There's only one that's different here. And then the period is different. So let's pick off the, let's try and find the amplitude on these things. Okay, so here, I'm going to try and find the whole height. So I'm just going to count ticks here. 1, 2, 3, 4, 5, 6, 7 ticks. Oh, that can't be right. 1, 2, 3, 4, 5, 6, 7, 8 ticks. Okay, so 8. So half of that would be 4. So 1, 2, 3, 4. This is midway right here. Sometimes I have a hard time seeing it. That would be the midline. So the midline is plus 1. So mid, y equals 1. Okay, so it can't be that one. All right, I know that one right away. Can't be that one. Then let's find out the period, because it could be this one or it could be that one for the period. So let's look at the very first point here and let's see where that happens again. So we go up, down, up. This is where it starts to repeat. So at 360 degrees. So period equals 360 degrees. But that's not the b value, right? B equals 360 divided by 360, which would be 1. So I'm going to go ahead and guess that we're talking about this guy right here, because this one is the only one with a b value of 1. So this is 4 cos x minus 90 degrees plus 1. Alrighty, let's look at this one now. So it's, well, let's look at this one and let's see which one is in here. And I think we're going to have to deal with the phase shift in this one, because this is a sine curve and a cos curve. So I think that's where that's going to come in. Let's just double check some stuff. So first things first, there's my midline. So it is plus 1. So it's not 2, so it's either 3 or 4. All right. They both have the same period, so I'm not going to bother finding the period because they're the same. You know what I mean? Like, I don't really want to deal with that. Now, let's deal with, is it a sine curve or cos curve, and what would the shift be if that was the case? So this is saying it's a sine curve that's been shifted to the right 60 degrees. So a sine curve would typically start here, it would go up and come down. It says it's been shifted to the right 60. So this would be the start, it would come up and then go down. So that's what this should look like. But I wouldn't say that that is what I'm looking at here. Oh, maybe it is. Let's see. Where's 60 degrees on here? 30, 60. So that would be 60 right there. That would be my starting point right there. So I go up and I come down. Yeah, that looks like a sine curve to me. So I would say that this is an accurate representation right here. Y equals 4 sine 3x minus 60. So that's just saying it starts at the midpoint. That's been shifted to the right 60. So instead of starting right here, We start right there, and that's what I see. I see it going, starting the midpoint, going up and then down. Nice. All right. Let's look at these guys. Actually, you try these on your own. Let's see how it goes, and then that's where we'll stop for today. All right. Thank you. Have a good night.